Okay, this part of the video is actually going to be made after I did the rest of the video, so you're going to see all the rest of the videos do skips when it shouldn't be, because I forgot to mention that if you're working with a slow drive, you need to change settings. So if you know you're working with a slow responding drive, meaning that every read or almost every read takes a long time no matter what, you need to change something in the settings. So let's look what happens if I don't change something in the settings. We're doing slow skips. It's skipping every time. There's no errors, but it's reading slow, so it's skipping. So we're going to stop it. Maybe. And what you really need to do is, for phase 1 and 2, the skip threshold. This is what triggers a skip. You want to turn this up. I'm gonna say turn it up to 10,000 milliseconds or 10 seconds for this drive, because I know the slow skip is only like 2 or 3 seconds. So this will make sure that it does not skip on slow. And we're gonna start again, and we're gonna see that as we're going along, it is no longer skipping, because we just don't want it to skip. That it will cause a skip reset after so long, and that will cause it to stop. And you don't want it. You don't want it skipping just because of a slow issue. I'm going to show you a bit of a trick on the best way to deal with drives suffering from a slow issue if you're unable to fix the firmware issue causing the slow responding problem. This is mostly for Western Digital drives, but it should, in theory, also work on a few Seagates with the same problem. So right now I have a drive connected. I already set it up. It's connected via USB. I'm using the default settings. I'm going to do a connect and then start. This is a Western Digital drive, and it definitely has a slow issue. So now we watch our current rate here just puddle along at about 31 kilobytes a second. So we will stop it, and alright, so now I'm going to the settings, and being that this is connected USB, I'm only going to be able to turn this up to 240 because it's the free version, just standard pass-through SCSI USB. Unfortunately, that is the limit with Linux, but let's watch this and give it a second. Now we're evened out at 58 kilobytes a second as compared to 31, so we almost doubled our speed by not quite doubling the cluster size. Well, the reason for this is simply that the slow issue is a background operation happening in between reads. And that background operation, whatever's going wrong, it's almost like there's a bad sector someplace. It just takes forever to read. You can see the time here. It's about 2 seconds. And there's nothing wrong with the sectors themselves that are being read. It's that background operation that happens in between every read, or almost every read. Sometimes it doesn't happen. Sometimes you get a spurt where it'll work. Read fast. But that's what's going on, and that's why increasing the cluster size helps mitigate the slow issue, because the bigger the read, the more data you're getting in between every background operation. Since this drive is actually a SATA drive, I have now connected it via SATA to the computer in a way that the OS can see it, so I'm still using pass-through. Default settings, already connected it so now I'm going to go to clone settings, and I'm going to turn the cluster size up to what will be the maximum of 1024 for the pass-through. That again is limited by Linux by a buffer. It's just the way it is. Let's see how fast it is now. Remember, we had 31 kilobits a second for 100 at first for 128 cluster size, and then at 240 we had 59. Now we're getting around 270, 271. So as you can see, our rate has greatly increased. But then again, this is a SATA drive. You might not get so lucky and be stuck with a USB, but USB direct is coming up in a little bit. So now I've connected this drive in a way that it's not seen by the OS, and I'm using the direct HCI mode. Clone settings, and when I did the open the program, it did not install the virtual driver on its own, so I'm still limited by a buffer, but this time it's my buffer. So now the maximum is 1984 for cluster size. So click OK, connect, start. Let's see what the rate goes up to. I'll give it a little bit to settle in. Well, on the 464, 68.4, you see significant improvement from before. But now, I'm going to disconnect. I am going to start the virtual disk driver, which actually gives a better memory access for my program. Now I should be able to turn this up to 4096 and see what happens. Oh, excuse me, I'm wrong. 8192? 8128. Okay, close enough. Got my numbers a little screwed up. But that's beside the point. Let's see what our rate turns into once our cluster size is turned up that much. As you can see, we're in the 1800, 1900 kilobytes a second area. That is a significant improvement from our original 31 kilobytes a second. Excuse me, yeah. Now I'm going to show you what happens when we use direct USB mode, where we're allowed to change the settings. Okay, this is going to take too long doing it that way. I'm just going to type in a high number and see what happens when I hit enter. Look, 65,520 is our cluster size. Then we'll wait a minute for it to settle in. Because I think there's some error. Well, you see 10 megabytes a second is about what we're doing. That is definitely a significant improvement over top of our measly 31 kilobytes a second. So you can see that the more you can increase the cluster size, the faster you can read a drive that has a slow responding issue.